Okay, so first of all, here we're going to look at the effect of, we have a bar magnet and a coil of wire. Now, when I start off, I'll start off just with a bulb to show you what happens in the real circuit. If I take the magnet and I move it into the coil, the bulb lights. If I move it out the coil, the bulb lights. If I leave it inside the coil, nothing happens. So, what we need here, for current to flow and the bulb to light up, we need magnetic field, we need electrons in the metal wire, and we need movement. So to get current flowing in the coil, the magnetic field from the magnet needs to move. So field, movement, and I get current. As I move it in, you can see the electrons have moved, little blue balls there, moved in one direction. As I put it out, you see little blue balls, the electrons have moved in the opposite direction. So to keep this ball lit up, I would have to keep the magnet in movement, keep the magnet moving, okay, which is what happens in a generator. But to see the effect of some of the changes that we can do here, I'm going to switch to the voltmeter. So the first thing that I'm going to do to see how it affects is move the magnet slowly in, slowly out. As it moved in, there's a little, the needle moved a little bit to left. As I moved it back out again, the needle moved a little bit to right. Let's change the speed of movement, how fast. Whoop. If I move the magnet fast, you can see there's a much bigger voltage. So increasing the speed or the rate at which the magnetic field is moving through the coil is going to increase the voltage. How about if I reduce the strength of the magnet? What effect is that going to have? Here, moving it in and out, and you can see it's ever such a little movement, and I increase the strength of the magnet, and bigger movement. Okay. What happens, for example, if I increase the number of loops? I can have 3 or I can have 1. So let's have 1. We get that much movement, and then 3, and I get much more movement. Okay. What about if I increase the area of the loop? Let's make the loop really big. And let's say make the loop smaller. What effect did that have? Okay, so from this app, what I'd like you to do in your notes is note down what effect does the speed, the rate at which the magnetic field moves through the coil, what effect does that have on the voltage? I want you to note down what effect changing the strength of the magnetic field has on the voltage, what effect changing the number of loops has on the voltage, and what effect changing the area or the size of the loops, what effect that has on the voltage. And the important thing here is that, remember the left hand rule. In the left hand rule we have movement, go for camera overlay. Okay, so remember here the left hand rule, movement, field, current. So if I have a field that moves, I get a current produced, and current is the movement of the electrons in the wire. What kind of current am I getting? Current goes one direction, goes the other direction, so this is alternating current. Okay, so make sure you've got these things noted down in your notes, and then we're happy.